For today, we're going to start moving into what we call reflection. So yesterday we talked about translation and dilation. Today we're going to talk about reflection. Now reflection, when I see the word reflection, I think of the word reflect. You know what happens on the mirror. So let's see. So imagine I have a mirror, usually something straight right here. And think on one side I have the letter R. I'm going to write the capital letter R. And then think what happens on the mirror, right? When you see it on the other side of the mirror, it looks the same, it just looks flipped, right? So reflection is basically things that are flipped. One thing on reflection, though, when you look at it in the mirror, something that is close to the mirror line, it looks like it's right there on the other side, right? So if you stand close to the mirror, it looks like you're on the other side, but pretty close to it as well. If you stand far away from the mirror, it looks like you're on the other side pretty far as well. Distance remains the same in reflection. So if you're close to the mirror line on one side, you're basically close on the other side. If you're far from the mirror on one side, you're going to be far from the mirror on the other side. Now, reflection, we're going to do it two ways. We're going to count spaces because distance remains the same, but sometimes we're going to use special cases. Special case, there's 4 special cases on reflection. It can reflect across the x-axis, the y-axis, the line y equals x, or the line y equals negative x. Now here on this notes, this is what I gave you guys, the cheat sheet. We can say little notes for the special cases. If it reflects across the x-axis, my values of x and y, all I'm going to do, I'm going to change the sign on the y. You guys see how my y here looks like negative y. It doesn't necessarily mean I'm going to make it negative. It means I'm going to change the sign. So if it was positive, yeah, change it to negative. But if it was negative to begin with, you're going to change it to positive. The negative of a negative becomes a positive. So all I'm going to do, if it's reflection across the x-axis, all I'm going to do is I'm going to change the sign of the x value. Now, if I have it reflection across the y-axis, you guys see how it says xy becomes negative xy? All I'm going to do is going to change the sign on the x value. Now, reflection across y equals x. It says xy is going to become yx. Okay, so my numbers are going to flip. The x is going to become the y value, and the y is going to become the x value. So the numbers are going to flip. And lastly, reflection across y equals negative x. xy is going to become negative y, negative x. So two things. My numbers are going to flip, and my signs are going to switch. All right. We're going to use this table, or we're going to count distance. Now let me show you what I mean with distance. Let's take a look at how we're going to be doing the work. For us to know where we're going to be stopping today, I'm going to be working questions 60 through 65. So let's take a look at question number 60. Let me see real quick here. Let me zoom in to number 60. I'm going to graph the image of the figure using the transformation given. Now, 2 lines that are very, very easy to get confused. We learned that in algebra 1, the lines were y equals a number and x equals a number. Now, these 2 are not special cases. So the 4 cases that I gave you, this is neither one. Okay, so the y equals -1. Now, interesting is that the x-axis, you guys see where the x-axis is. Another name that we have for the x-axis is the y equals 0 line. And the reason why we also call it y equals 0, it's because any point on that line, the y value is 0. So on the x-axis, any point, it has a coordinate value y equal to 0. So another name of that line is y equals 0. Notice I switched the letter. The x-axis, I called it y equals 0. So the line y equals -1, because I have to reflect this across y equals -1, should look like the x-axis, should be parallel to the x-axis, is just going to be 1 down. So the mirror line, let me do it in red, is going to be this line. This is the line y equals -1. We're going to identify the mirror line. Now, what I'm going to do for reflection, I'm going to move everything from one side to the other side. In this case, my points are above the line, right there on top. So I'm going to bring him to the bottom, but I'm going to count spaces. If I look at my point F, I count the spaces to the mirror line, right? I count 1, 2, 3 spaces. So on the other side of the mirror line, I'm going to count 3 spaces as well. 1, 2, 3. So that's going to give me my point F prime right there. I look at my point G. I'm going to count spaces to the mirror line. There's 1, 2, 3, 4. So on the other side of the mirror line, I'm going to count 4 spaces. And that's going to give me my point G prime right here. Remember I said, if you're close to the mirror line on one side, you're close on the other side. If you're far from the mirror line on one side, you're far on the other side. So we are counting spaces. When I look at my point H, I'm going to count the distance from point H to the mirror line is 1, 2, 3 spaces. So I'm going to count 3 spaces on the other side. So this is my point H prime. When I connect my points, it looks like the triangle that we have, it got flipped. Remember I said on the mirror line, everything gets flipped. So it looked like my image got flipped. The size of the image should remain the same. It just got flipped. So that is congruent, right? Same shape, same size. Let's take a look at question number 61. The mirror line in this case is going to be the line x equals -1. Now in this case, I'm going to use the y-axis. The y-axis, another name that the y-axis has is x equals 0, right? X equals 0. Remember back in Algebra 1, when you guys learned how to graph lines, the y-intercept, when you guys did slope-intercept form, the y-intercept, they said, oh, the x value is 0. Yeah, so that's another name that we have for the y-axis. We call it the line x equals 0 because any point on that line has the x value 0. Now the line x equals -1 should be this line. I move to the left because on the x-axis, to the left, you go to negative, you go to the left, positive, you go to the right. So x equals -1 looks like that. That's the mirror line. Now let me reflect everything from one side to the other. Let me take a look at my point F. I count how many spaces my F is to the mirror line. It's 2 spaces. So let me count it 2 spaces on the other side. Notice I start counting from the mirror line. So there's my point F prime. I look at my point G. Is 1, 2, 3 spaces to the mirror line. So I'm going to count 3 spaces on the other side. And my point G prime is right there. Now, point E is very interesting because point E is on the mirror line. Any point on the mirror line doesn't move. So my point E prime will be right there. Now, technically, it is 0 spaces to the left, so it will be 0 spaces to the right. It doesn't move. Any point on the mirror line, it doesn't move. So I connect my points, and it looks like my image just got flipped. Couple things I want to emphasize here. When I have y equals a number, my line is horizontal. You guys see the line y equals -1, right? Remember the x-axis is y equals 0. So the line that I did there is the line y equals -1. So when it's y equals a number, the line is horizontal. When the line is x equals a number, in this case, x equals -1, my line is vertical. That means my line goes up and down. Okay, so a couple of things I want to emphasize. And then when it comes to reflection, I count the distance. So I counted the distance on one side and it reflected on the other side. Now for your homework, I'm just going to ask for the coordinates of a specific point. If you can do one point, I'm pretty sure you can do the others. Now these were not special cases, so I didn't use the special cases rules. Now let's take a look at question number 62. Let me draw the line y equals negative x. I'm going to reflect it across the line y equals negative x. Remember, the slope is a -1. We learned back in algebra 1, that line is this one right here. That is the line y equals x. Now I can reflect things two different ways. One, I'm going to count distance. I'm going to count the distance. So I'm just going to say, all right, I'm going to count diagonal in this case. I look at my point x. To the mirrored, it takes me, let's say, 1, 2.5 spaces. 2.5. So let me count 2.5 on the other side, diagonal. And this is going to give me my point x prime. If I look at my point W, is one space from the mirror line. So let me count one space on the other side. And here's my point W prime. And same thing with V. I'm going to count diagonal. There's 1, 2, 3 spaces. So let me count 3 spaces on the other side. And there's my point V prime. I connect my points. And it looks like my image got flipped, which is what I was expecting. So that's one way, right? If I'm asking for V prime, just do it to V and give me the coordinates of V prime. If I ask you for the coordinates of X prime or W prime, whatever you want. That's one way of doing it. Another way we could have done this, let me get the coordinates of the points that I have. So V, the original points, V, W, and X. The coordinates of V are -5, -1. The coordinates of W are -2, 0. And the coordinates of X are -1, -4. Like I said, I got the original points. I remember the rules, the special cases that I gave you when it goes across the line y equals -x. I know the special cases, it says xy. If you look back on the notes, it says xy becomes -y, -x. So what I'm going to do, I'm going to flip my numbers and change the signs. So V prime, the coordinates of V prime should be 1, 5. So let me use blue for this one. V prime should be the coordinates 1, 5. The numbers flip, right? The X and the Y value flipped and the signs switch as well. And if you look at my point V prime, yep, the coordinates are 1, 5. The coordinates of W prime are going to be 0, 2. Now there's one thing. There's no such thing as a -0. Remember I said I'm going to switch the signs, right? The numbers flip and then I switch the signs. There's no such thing as a -0. So 0 is still 0. And the coordinates of X prime should be 4, 1. So I can do it counting spaces like we did, or I can just use the notes. Now let's take a look at question number 63. Reflection across the x-axis. Let me do it counting spaces first, okay? The x-axis is right here. And I said I'm going to move everything from one side to the other side. I'm going to count spaces. So D is 3 spaces down. So on the other side, I'm gonna count 3 spaces. That gives me D prime. I see B, let me count the spaces. 1, 2, 3, 4. So 4 spaces on the other side, that is B prime. C is actually on the mirror line, so it doesn't move. Remember, any point on the mirror line, it doesn't move. When I connect my points, it does look like my image got flipped, which is pretty much what I was expecting. Now in the homework, I'm going to ask for the coordinates of a specific point. So if I ask you for B prime, just give me the coordinates of B prime. If I ask for the coordinates of D prime, just give me the coordinates of D prime or C prime, whichever one I ask. That's one way, counting spaces. Another way we could do this, let me get the original value. So the point C is a -3, 0. Point B, except the original points, is -2, -4. And point D is 0, -3. When I look on the notes, right, we have our questions here. We have the notes, the question 51, reflection across the x-axis. It says xy. I'm reading the notes on question number 51. Xy becomes x -y. So all I'm going to do is I'm going to switch the sign on the y value. Right? If it's positive, move it to negative. If it's negative, switch it to positive. Switch the sign of the y value. So C prime should be -3, 0. Right? There's no such thing as a -0. Right? I'm not going to write -3, -0. There's no such thing as a -0. Now my B prime will be -2, +4. Notice I switched the sign on the y value. And my coordinates of D prime should be 0, 3. Again, I switched the sign on the y value. So we can do it counting spaces, or we can just use the notes on question 51. Now, my last two examples for today, I am going to use the notes from 51. So here it says, reflection across y equals -x. And I see on question 51, it says xy is going to become -y, -x. So my x and my y value are going to flip, and my signs are going to switch. So with that said, v prime will be 2, 2. W prime will be 0, 3. I switch the sign. There's no such thing as a -0. So I switch the signs, but I also flip my numbers. X prime will be 1, 1. It doesn't look like my x and my y value flip, but they did. And my y prime will be 4, -2. Notice I switched the signs. The 4 was negative to begin with, so I put it into positive. The 2 was positive to begin with, so I moved it to negative. Now, question 65. Let's take a look at 65, our last question for today. Reflection across the x-axis. According to the notes on question number 51, reflection across the x-axis, it says xy will become x -y. So all I'm going to do, I'm going to switch the sign on the y value. So if I want to know the coordinates of v prime, it's going to become 1, 1. Notice how the y value, I switched the sign. It was negative, so I made it to positive. W prime will be 2, -2. Notice I switched the sign on the y value. X prime, the coordinates of x prime will be 4, -1. And the coordinates of y prime will be 5, +4. All I did was switch the sign on the y value. All right, let me zoom out. That way you guys can see what we did. We saw reflection today.